I'd like to start by giving thanks to my mentor, Gavin Halliday, for his work in my project. Let's start with a poll question, which is, have you heard of the workflow and its use when processing ECL queries? You should be able to submit your response below, and we'll cover the answers at the end of the presentation. I'd recommend that you go into full screen for this presentation so that you can make the most of the diagrams. I've decided to split the presentation into two sections. First, I'm going to describe the workflow and give you a taste of the purpose of the workflow. And then I'll describe the details of how my project has been implemented. And that way you'll find out why the project is useful. When ECL programmers submit a query, the work unit goes through two stages, as is shown by the flowchart on the left. Firstly, the query gets compiled by the code generator, and then the agent uses the helper files that the code generator produces to perform the work of the query. My project has been concerned with two of the helper files, the workunit XML, which describes the metadata of the query, and a shared object which contains some compiled C++ code. And the code contains the activity graphs for the query. And each activity graph gets produced when the ECL programmer uses a dataset operation such as sort or dedupe, and they correspond to the work that has to be done. The workflow is one section of the workunit XML, and it's made up of workflow items. The items are related to each other by dependencies. For example, here, workflow item 2 has to be executed after workflow item 1 because it has a dependency on it. For each item, they have a number of activity graphs that they will call to execute. And the agent therefore uses the workflow to determine the order that the activity graphs are executed in. One part of the agent is the workflow engine, and its role is to traverse the workflow to perform the items and therefore the activities in the correct order. For the existing system, it uses a sequential workflow engine, which takes the items one at a time. In this example, you see that it starts at item 9, which is called the parent item, and that's because it's the item that will execute last. It takes each item in turn, starting from item 9, and executes any dependencies of that item. So you can see that it will traverse the workflow down to item 1. Once it's performed item 1, it will perform the other dependency that belongs to item 3, which is item 2. And after doing that, it will retrace its steps through the workflow. It will do exactly the same on the right side of the diagram for the condition item, which is a way that ECL programmers can use conditional execution. Once it performs item 5, it will select one of the two branches to recurse down, in this case choosing the right branch. And once it's executed that item and returned to item 9, the sequential workflow engine knows that the query is complete because it will have performed all of the items. A handy feature of ECL Watch shows the timeline of the work unit, and you can see here that the items are the blue lines in the top diagram, and they're performed one at a time. The goal for the parallel engine is to increase the scope that the HPCC systems implements parallelism into the program by executing several items all at the same time. and you can see how this would reduce the total running time of each work unit. To give you a taste of the diagrams that will be in the second half of the presentation, I thought I'd include this one to show how 3 different threads could halve the time that the query takes to execute, because only one of the threads has to perform 4 items. And the idea behind how the threads get these items is they begin them as soon as they're ready, which is as soon as all of the dependencies of the given item have been executed. I've color-coded them to show how many generations of dependencies each item has. This is the ideal behavior of the parallel engine. I'll be explaining the challenges that I had to face in my project to implement this. This diagram here shows the structure of the parallel engine that I designed. It has a thread pool which is there to make sure that idle threads which haven't yet got items or have finished executing items don't consume computer resources. And it uses a semaphore to alert the threads and tell them when items are ready to be popped from a queue of items. And this way, instead of just processing one item at a time, each thread is operating fairly independently and is able to execute items individually. The thread can be in one of 3 processes. It can be waiting, it can be actively executing an item that it's popped from the queue, or it can be adding new items to the queue that correspond to the successors of the item it's just performed. ECL programmers are provided with a number of workflow services that they can use to control the order of execution of the query. For example, the workflow mode sequential is used by programmers to specify when items or actions have to be performed in a certain order. For example, the programmer might want to ensure that any new data is ingested before they perform batch operations to generate results from that data. I ordered the sets of workflow modes into a high priority list and a lower priority list for my project. And the reason I did this was to separate the modes that are most commonly used and the modes that are most useful, and to ensure that by the end of my internship I will have implemented those. I went through an incremental design process for my project because I entered it without knowing anything about the sequential workflow engine, let alone how the parallel engine should work. So for each mode, starting with the simplest, I designed what I thought the solution would be, and then after implementing it, I had to test it with the previous modes to make sure that they worked well together. Here, the middle and left diagram show that the parallel engine is using the dependencies of the workflow in reverse order. Instead of parents telling their children when to execute, the children, when they're being processed by the threads then go on to add the parents to the item queue. The parallel mode is used by ECL programmers to specify that the items should be allowed to execute concurrently, but it doesn't force this. What the parallel engine does is it makes it much more likely that when the parallel operation is used, they will actually be performed concurrently. Here I've included diagrams for each of the different modes, and one challenge of ordered and sequential was to try and understand the implicit dependencies that using such a mode introduces. For example, it's not recorded in the workflow, but we know that item 2 needs to execute before item 3, and item 4 needs to wait till item 3 has finished before starting. However, I discovered that a challenge to trying to implement this was that if implicit dependencies were just naively thrown in, it would cause this particular example to never start. I decided to use the idea of active and inactive items in the workflow to grasp the concept that some items were ready and some items weren't, even if all their dependencies had finished. Here are the other modes. One challenge of contingency clauses was to try and guarantee that the workflow finishes at the correct time, because it's starting off the engine on a separate branch. Persist items introduced a challenge in that the agents were responsible for handling the locks on the persist. And what's useful about persist is that ECL programmers can share tasks between queries, and it acts as a checkpoint. So if the query fails, then the result of any persisted item gets stored and therefore won't have to be re-executed if the query is resubmitted. The challenge that this introduced for the project was that some of the persist elements of the agent weren't designed for multi-threading, so I had to go through and make it thread safe. This last set of challenges for implementing the parallel engine come when the workflow fails. There's a specific behavior that the sequential engine exhibits when it fails, which is that all the items go back to their parent items and share the failure with them. And this happens because it's usually a recursive function, so the exception just gets thrown from one item to the previous. With the parallel engine, I had to manage this more actively and make sure that the right items were having the exceptions passed on to them. In particular, if there were ordered or sequential statements, then only the item that was active should receive the exception. The benefits of the parallel engine are that all work units will either be the same speed that they were before or faster. Another one is that there's no time penalty for ECL programmers if they want to use multi-purpose queries, and that's because related tasks can be performed in parallel and neither of them will slow down the execution of the other one. I hope you've seen some of the challenges I had to tackle when introducing the parallel engine, and I'm looking forward to when it becomes the default mode, hopefully in an upcoming release, and this will bring benefits to all ECL programmers. Let's close with a second poll question, which is, will the parallel engine impact the way that you write ECL queries? And just submit what you think the answer might be.
All right, wonderful. Thank you so much, Nathan. While you take a moment and look at the questions that have come in from the audience, and also for our audience, this is a wonderful time for you to submit questions for Nathan. We're going to take a look at the votes from the audience. So the first poll question was, have you heard of the workflow and its use when processing ECL queries? 87% said yes, so that's great news, and 12% had said no. So if you're the 12%, hopefully you've learned something useful for you today. All right, we're going to take a quick moment to look at the questions from the audience. Nathan, are you ready?
Yes, I'm ready.
All right, let's start with the first one. So the question is, will your project have a particular impact on cloud environments?
The answer is a mixture. So the project will have an impact on both cloud environments and bare metal installations. it has a particular benefit on the cloud, which is that new clusters can be spun up as needed if full jobs are being passed. And that means that there isn't a limit to how many items can be processed in parallel. On the other hand, for bare metal systems, by providing the clusters of Thor and Roxy with work sooner, it makes sure that they're not wasting computing resources. So it has potential to save money.
All right, perfect. Thank you. So here's the second question for you. Have you dealt with multi-threading issues?
I have, and in particular, I had to adapt how the agents were storing the current graph that was being executed, because it was no longer the case that just one graph would be processed at a time. So that had to be passed as an argument to the necessary functions. And I also had to do some research about the use of critical sections and mutex locks in order to protect code from race conditions. So there are certain parts of my code that implement those.
Okay, good. All right, here's another question for you. Does your project change the results of ECL code?
One of the key things for my project was making sure that it preserved the behavior of the sequential engine. So I'm fairly confident, and I'm hoping that all queries that go through the parallel engine will behave exactly the same as they would have done, but they'll be faster.
Okay. So it looks like we've had another question come in, a few more questions come in. So I'm going to go ahead and read the votes from the audience for your last poll while you look at those. All right. So your last poll question was, will the parallel engine impact the way that you write ECL queries? So 11% have said yes, 22% said probably, 33% said probably not, and the remaining are the no and the not applicable. But that's a pretty good number that you could probably have learned something from your project, Nathan, so that's really good. All right, let's take a quick peek at these last two questions that have come in from the audience. So the first one is, so parallel currently doesn't force parallel execution. So will this change make more parallel execution happen?
That's a great question. I think the answer is yes, particularly because the sequential engine wasn't capable of performing items in parallel. But I know that there are other parts of the system that do use the parallel command to allow parallel execution. So it will happen more often, but it was already happening.
Okay, thank you. All right, here is a perfect question. Where can I read more about your project? Do you have a blog?
I have a weekly blog, which hopefully is one of the attachments to this presentation. And Lorraine mentioned that on the main HPC systems blog page, I've worked on a blog post, and that's there as well.
Wonderful. And we've also been promoting these, our intern blog. We've been promoting them through our social channels. So if you look on our Facebook page or Twitter or LinkedIn page, you can also find links to Nathan's project as well as our other interns. Wonderful. All right, Nathan, you are off the hot seat. Excellent presentation. Thank you very much.
Thank you.